and then I'll give you permission to screen share.
Let's see.
There you go.
Okay.
Now let's see, it's still recording. Yeah, still shows as recording. You should be able to screen share. Good. All right, I got it here in this recording.
Perfect.
All right, so what I'll do, I said, okay, I'll go ahead and start. Well, let's see, Ahmad Amanullah, right?
Yep, you got it.
Ahmad Amanullah will be talking to us about win streaks in the NBA and to see what sort of correlation there is between a team's longest win streak in a season and its win-loss percentage. This is not as straightforward as a problem as it may appear, because it is possible for a low-win, a relatively low-win team to have a long streak just by chance, or injuries or things like that. So without further ado, let's like Ahmad said, Ahmad, take it from here.
Awesome. So as Dr. Nanya said, this is about basketball. So I'm an avid fan of basketball in general. So I love watching it, I love playing it in my free time as well. And so I was super interested to see how winning is correlated with, or the overall win-loss ratio is correlated with the win streaks, and vice versa as well. So, and then one bonus thing is that, of course, living in Illinois, we have to obviously support our Bulls. They made it to the playoffs, but got eliminated in the first round. But hopefully next season. So just a bit of background information that I should mention. So first off, there was a study done in 1985. It was done by Gilovich, Balon, and Tversky. And their study is called Hot Hands. And so in that study, they wanted to see if players with hot hands had they were more likely to make a shot, their next shot. And if, for those who don't know, a player who has hot hands, that basically means that they're on a streak of making multiple shots in a row, and then they get the turn of being held with hot hands. And so what the study wanted to see was that these players who have hot hands, if they're likely to make they're more likely to make successive shots. So what they actually ended up finding was that there was actually no positive correlation between players who have the hot hand and them making successive shots. So then from there, that basically inspired us to think, but what about teams? Hot teams, do they have a higher chance of winning successive games in a row? So when looking at that, we're like, okay, let's see if these hot teams can go on better streaks or not. So do they have better streaks? And then vice versa as well. Do these better streaks end up coming in with a better win percentage for those teams who go on better win streaks? So the season that I wanted to really take a look at was the 2018-2019 season. It was the last normal quote unquote season. So obviously the 2019-2020 season was disrupted by the COVID pandemic. And then from that, and then thereon, the format has slightly changed, but this was the 18-19 season was the last normal one, so to say. So they still had the 82 games played throughout the season. And then the top 8 teams in the West and the top 8 teams in the East would then proceed to the playoffs and then eventually battle it out for the overall champion. And in that season in particular, it was the Toronto Raptors who ended up winning the championship, defeating the Warriors. So that was definitely a big upset. But anyways, the goal was to figure out how the team's longest win streak is related to their overall win percentage, if at all, if it's related. And then we also wanted to see how a team's win percentage would be related to the longest win streak that they go on. So these were the 2 main questions that we were interested in. And then we'll take a look at 2 scenarios that is really interesting to look at as well. And we'll get to that in just a moment. So first of all, what we need to get was the win-loss percentage for every single team during that season. And then we also needed to get their longest win streak as well. So first things that I noticed upon pulling these stats was that the number one seed for the East and the West. So in the East, the Milwaukee Bucks had a 0.732 win-loss percentage, and the longest streak was only 7. However, if we look at the Golden State Warriors, they had a lower percentage, 0.695, but they won 11 win streaks. So it seems like somehow a lower percentage won more games in this case, but we'll see how our math lines up. And then one extra note that I wanted to make was that it's kind of just a random fact was that the Phoenix Suns in this season that I'm analyzing, they're actually the last seed in the West, and then they're in the bottom 3 overall for the when taking a look at the overall standings. And then this season they're somehow the number 1 seed in the West. So it's interesting to see that they've made such a big comeback. But anyway, that was just a side tangent. So given all that data, we needed to first figure out some information. So using the geometric distribution, we actually had to specifically look at the cumulative density function, or the CDF. And so the equation is given right there. And so in this case, N is, or let's start with P first. So P is just the win percentage, and then 1 minus P, or Q, would be the loss percentage. And then the N would be the win streak that a team went on. So in this case, the highest win streak in the season was 11 by the Golden State Warriors. So we decided to go to N equals 12 just to give a little bit more space on that end. So upon calculating the CDF, we then went on to calculate the expectation for the win streaks. And so what we found out was that the expected streaks, or the expected streak, was actually, it was kind of on the lower end. But the thing is that the actual win streaks ended up being within 1 standard deviation of the expected value for quite a few of the teams. But then at the same time, there were a few teams whose actual win streak was actually within 2 standard deviations of the expected value for the streak. So in our textbook, the stats textbook, Wiley states that about 95% of the data should lie within 2 standard deviations. And in this case, all the data was within 95%, or within the 2 standard deviations. So there's nothing too absurd about that. That's about a good estimate or a good correlation right there. But moving on, we wanted to see if there was a correlation between the win streak and the win-loss percentage. So on this graph, I basically plotted out the highest win streak for every single team. So one that I mentioned was the Golden State Warriors with an 11-game win streak. And then obviously this goes down or up, which is a positive correlation. So that's the linear regression for the streaks and the win-loss percentage. So I ran the ANOVA test on this set of data. And what I found was that the correlation coefficient came out to be 0.82, which is a really strong correlation. And then from there was also another value in the ANOVA table, which was the R-squared value, which actually explains how much of the variance in the win percentage is actually due to the variance in the win streaks. So that R-squared value actually came out to be 0.65. And then one thing you'll notice is that at the top of the graph, right up there, there's actually an equation for the line, for the best fit line for the linear regression. It's 0.0533x plus 0.193. So in this equation, x is actually the number of games in a given win streak by a team. And then the 0.053 actually correlates to how much each game in a given win streak adds to the overall win-loss percentage for a given team that season. And then next thing was to figure out the confidence interval for the linear regression. So we use the top equation up there. The equation is again from our textbook. And in this case, beta naught would be the 0.0193, beta 1 hat would be the 0.0533, and then plus minus t, which is the stat we decided to use because n equals 30. So that's about the cutoff for between t and z. between the T and Z stat. So we decided to go with T. Then, as I said, N is 30. So upon plotting it, which is the black two lines, we saw that pretty much all the teams seem to have fit within that confidence interval. But there is one team right over here that seems to have just kind of barely made the cutoff. It's slightly below the cutoff, actually. And that team is actually the Sacramento Kings. They had a win-loss ratio of 0.47, but their overall, so they actually went on a 9-win streak, but their ratio was 0.47. So unfortunately, they didn't quite make the cutoff. So as you would see, a team who went on a 9-win streak, they would be expected to have a slightly higher win-loss percentage. But the Kings obviously did not make that. So that was one of the teams that was an outlier, so to say, in this case. So the next thing that we wanted to look at was the order statistics. And so with this, we were actually able to see if there was how the win percentage would affect the win streak. So in the first part, we just saw how the win streak itself would actually affect the win percentage. Now we're just switching it around. How does the win percentage actually predict the win streak itself? So in this case, we actually had to use the exponential. We have to use the exponential approximation for the geometric distribution. And that's actually because the density function of the maximum order statistic of the geometric distribution is actually not closed or is not existent in a closed form. So in order to figure out the win streak, we had to use the equation as listed here. And again, this is from Blackfield. So in this case, N would be the number of streaks that were observed in the season, which was, and we used N equals 8 just to account for any loss streaks that were there. And then P would be the loss percentage in this case. And then one additional thing to note is that for the integral, it's on here it's listed as 0 to infinity, but obviously the integral would become a little bit too cumbersome to evaluate from 0 to infinity. So we decided to use the upper bound of 100, and that would sufficiently do the job. And so what we were able to get from this was the expected value for the streak and the variance as well. And what we found was that almost all the teams fell within one standard deviation of the expected win streak that they were supposed to go on. Again, there's only one team that did not make the cutoff within one standard deviation. They actually went into 2 standard deviations away from the expected win streak, and that was the Sacramento Kings. And so that means that since the teams were within 2 standard deviations, that means that there's a good correlation between the win percentage and the expected win streak. Again, by Barkley, 95% of the data should lie within 2 standard deviations, so that's a good distribution. So far, we've looked at how the streaks affect or can predict the win percentage and how the win percentage can predict the win streak. So now we want to look at some extreme cases, or what an outsider would perceive it as extreme cases. So 2 teams that we decided to look at was the 1972-73 Lakers and the 2007-2008 Rockets. And so with these 2 teams, we actually found that the Lakers in that season went on a 33-game win streak, which is an NBA record for the longest win streak to ever have, for a team to have ever gone on. And they did it with a 0.84 win-loss record. And their overall record was 69-13. So that's a very, very good record for that team. So now let's take a look at the Rockets. So they have a much lower overall record, or a win-loss ratio of 0.67, and they were 55-27. But they somehow went on a 22-game win streak. So that's definitely a remarkable win streak nonetheless. But is that really reasonable though for a team like that compared to the Lakers with a 0.84 record and 33 games? So starting off with the Lakers, we actually found out that the expectation was only 17 games, but the 33-game win streak still lies just about 2 standard deviations within the expectation. So that's still not a really absurd win streak to go on. It's, yes, it's 2 standard deviations, but still from a statistical point of view, that's still not that bad. But then what about the Rockets? Obviously, we can get a hint that we are comparing these two teams. So there must be something with the Houston Rockets that makes it really special. So the expectation was 8 games to go on an 8-game win streak, given their win-loss ratio. And then they somehow went on a 22-game win streak, and that was just about 3.6 standard deviations away from the expectation. So that is way, way far out there. So by Wackerly's book, he says that about 99% of the data lies within 3 standard deviations, but this is far beyond 3 standard deviations. So this is very much of an outlier. So when comparing these two teams, yes, the Lakers went on a 33-game win streak. Yes, they have the longest win streak record, but that was still reasonable, so to say. The Rockets, however, that is a very long and absurd win streak to go on from a statistical point of view.
Yes, even the Bulls didn't have a win streak that long, did they?
No, yeah, the Bulls did not even make it that long, despite having a better record, though.
Yeah, much better record, but yes,
Yep.
70 some odd wins and nowhere near that streak.
Exactly.
So,
Yeah, so the Bulls would be in between these two, and obviously they did have an expectation a little bit closer to the Lakers, but their standard deviation was around 2 for them. But then the Rockets, they just somehow miraculously went on a 22-game win streak, given the record. This is definitely one of those outlier teams for that season, and overall as well. So all in all, the past 34 months, we've been crunching the numbers. We finally come to have some results. We've figured out that based on a team's longest win streak, we can actually we can actually find a positive correlation between the overall win-loss record given the team's longest win streak. And in this case, the 18-19 season, each game adds about 0.0533 to the overall win-loss ratio. And then we were also able to figure out that based on a team's win percentage, we can also predict the longest win streak, but it's within 2 standard deviations of the expected value. So these 2 findings I found really interesting. I did not expect that we would be able to narrow in so much to the point where we would be able to predict one thing from another, especially in basketball, which I thought was completely random, but there's a correlation between the 2. But then obviously there's some exceptional teams that sometimes don't exactly make the cutoff. Lakers, despite their 33-game win streak, they do make the cutoffs to where it's expected, but the Rockets are one of those rare instances where this conclusion doesn't quite hold for them. But in general, our results do hold. The Rockets are just some crazy team that miraculously did not fit in. And that's it all. Thank you so much. Thank you, Dr. Anyas, for guiding me through this process.
Thank you very much. I'll go ahead and then what I'll do is go ahead and participants, and I'll take I'll go ahead and all right. Thank you very much. Well, I'll go ahead and stop. I'll go ahead and sign out, and then we'll go ahead and close this.